Hello respected judges, our problem statement code is 1392 and the problem statement title is E-Waste Facility Locator. The ideas that have been included in our project are, it is an e-waste facility locator that gives information about the nearest e-waste centers to the user so that the user can dispose their e-waste properly. The software can tell the percentage of metal in the e-waste, that is when the user can upload a scanned device image or even the product ID number on our website through which the metal percentage can be told. This metal percentage that has been detected in the e-waste can be used to negotiate prices between the facility centers and the user. A chatbot is provided that gives user e-waste related information. A portal is provided to sell the working parts by the centers to the users on our website, and pickup and drop facility is also given here. The website provides educational pop-ups to the user, that is information related to e-waste, their effects, the awareness regarding e-waste, etc. To keep the user engaging, a quiz section is given. It's like a mini game where the user has to first watch a 30-second video that is AI generated, and based on this video, questions will be given to the user to be answered, and those questions are basically ranging from basic to advanced, and based on the correct questions answered, a score will be provided. So we've also kept scoreboards to keep a track of the user's progress here. Now let us see the diagram here. The user will first visit the website or either can also log in to the website and will get an educational pop-up. When the user grants the location access, current location gets detected on the geolocation using Google Maps API, and will show the user the details about the proximate centers on the map near the user so that the user can visit the center for their disposal of e-waste. Now the user can visit the trivia section, can give a quiz related to this 30-second AI generated video, and can see their score on the leaderboard that is provided. Now when the user can also read and write a blog, that is, the user can write a blog about e-waste, about how they dispose their e-waste, tips on disposing e-waste, etc., and the other users can read this. The user can detect e-waste metals and can earn credits, that is based on the amount of precious metals that have been extracted. The user will be rewarded credit points or coupons that they can avail later, and the percentage of metal will now allow the user to negotiate the prices between the facility centers. The technology stack that has been used here is the front end. For front end, we use HTML, CSS, JavaScript. For back end, we use Django and MySQL. And in machine learning, we've used Python models that is TensorFlow, Skyscraper, Pandas for training the software for metal detection using training data sets through case studies. Now, the use cases, we've divided the users of the website into three parts. That is the user itself, the e-waste facility center, and the administrator. The user can do the registration and login, can find the proximate facility centers, can use the trivia section to enhance their knowledge. The e-waste facility centers, contact numbers, our email is also provided on the website for the users to use. The user can rate and can provide feedback to the facility centers. The user can also buy the working parts from the facility centers on the website, and a quiz section is provided for the users to play a fun game and also learn. For the e-waste facility centers, they can also do the registration and login. They can provide the exchange rates to the users so that they can earn as well about related to what e-waste they are giving the facility centers to dispose. Here we can also use the metal percentage. They can also check their ratings that the users have given and can send functional parts of products to the users. For administrators, they can add, remove, update e-waste facility centers, manage the frequently asked questions section and the quiz sections. The dependencies that have been used here are the Google Maps API to provide directions to the nearest facility centers to the users, and Google Places API for better user experience by auto-filling the search bar with appropriate addresses. So the user doesn't have to type in the entire place. The autofill feature will provide the user with their related thing. The showstoppers are basic. The website will enhance the user's knowledge because of educational pop-ups, engaging quizzes, facts that will be provided on the website. The user can automatically, the user's location will be automatically determined using once the user grants access, and the nearest e-waste centers will be provided here. The website will also provide the user to rate the facility centers and give a feedback. The facility centers have an option to display their fundamental exchange rates for the users to earn as well. The portal will provide the facility centers to sell their working products to to the users, which the users can buy looking on the website. And the website here does not utilize third-party applications. That is, it is a direct communication between the user and the facility centers, and there is no third party that is required to communicate between these users. Thank you. This is our project. Thanks.
So coming to the prototype, we have included few of the major use cases and features that we discussed in the PPT. First of all, as you can see, as soon as you land on the home page, you are greeted with the random fact of the day. So this changes dynamically each day and basically helps user to get more familiar with what e-waste exactly is and how can one recycle it. This carousel just depicts the current state of e-waste in our society. Now if you scroll down a little, you'll see two options. As the name suggests, in the location section, you'll be able to view all the nearest e-waste centers in your vicinity. For this, we first collected a list of all the e-waste centers in the cities along with their longitude and latitude. Then using the Google Maps API, we were able to place the markers on the map to the corresponding longitude and latitude of the e-waste centers. Further on, we also plan to add this city feature, wherein the user will not only be able to view the nearby centers, but also the centers in different cities as well. Now to play the trivia and get to know more of the features in our product, the user will have to log in first. Since I already have an account, I'll just log in into the website. Now to play the trivia, it basically contains a few of the MCQs based on e-waste and its effects. Here, instead of one question per attempt, we plan to add a list of questions which when the user submits, he will be rewarded with points and the name of the top 5 users will be on our leaderboard section. Now to scroll down a little more again, you'll see this new metal miner section. This basically lets users know how much percentage of precious metals can be extracted and is recyclable from their device. For this tool, we have created our own dataset and use an extensive ML algorithm to identify the metal percentage. As shown, the user simply has to write down their device name or ID and press the submit button. Next, you can see the percentage of metals recyclable will be displayed in a matter of seconds. Yes, that's all for the prototype for now.